Okay, Rainier. Here, so I'm here with Luna, as I always am, and we're making a YouTube video. This YouTube video is a little bit early. I'm just working on it ahead of time, so if you see this, probably before late February, you don't need to worry about it. We'll get to it in the future, but I'm just recording the video early. So I'm going to bring up our assignment. Our assignment has to do with mapping volcanoes on Google Maps. So you will find your copy in Google Classroom, where we post everything. My copy is a little bit different. Right? Again, I'm going to zoom in so we can read. It's going a little bit slow, but that's no surprise. 200%! Okay, so as always, we're typing our name and stuff in the boxes. That's where we're putting our answers. Our learning target and objective is to investigate the relationship between volcanic activity and plate boundaries, and also explore how the kinds of rock that is formed at volcanoes depends on the type of plate boundary. Great. So we should have already done this reading in class. We should have already highlighted the vocabulary words. We should have looked at this convergent plate boundary. We should have looked at this other type of convergent plate boundary. We should have talked about the mid-ocean ridge, transform plate boundary. Here's some summary of some of the other vocabulary. And here's our procedure. So in this activity, you will plot the locations of volcanoes using different colored Google Map pins. And I should add an S there for each kind of rock associated with it. From your finished map and other sources, you will consider whether the plate boundaries occur at the locations you have plotted. If you think that they do, you will try to determine the type of plate boundary. So it says, using the longitude and latitude coordinates in table 2.1, we're going to plot all the volcanoes in our custom Google Map file. So table 2.1, that's down here at the bottom, or not quite the bottom, but it says table 2.1 in big letters. Shows us a bunch of volcanoes. How many volcanoes does it show us? 32 volcanoes. And it gives us some information about them. It tells us the location. We have the common name and then the geographical coordinates. And it tells us the magma's composition. And scientists look at the magma composition to help determine the type of rock that it is. And we can see that we have the different types of rock over here. So what we're going to do is we're going to create a new tab. It's going to take us to Google, and we're going to type in Google My Maps. Search. And it should be this first one that pops up, google.com/mymaps. So I will click on it. It's going to load. So here are some maps, shows you all the ones you owned. You probably aren't going to have any. These are ones that I was playing with. We are going to hit this create a new map button. You can do this, computer. I know you can. All. Okay, there was an error. We're going to just start over, because sometimes sometimes we just need to start over. So we'll try Google My Maps again. We'll search it. Click on the first link. Okay, so I can see a bunch of untitled maps came up. So we'll hit create new map one more time. Okay, and now it worked properly. So this is what you should see. We're going to go back to the instructions and we're going to read it. So it says plot all the volcanoes using this custom file. Note that table 2.1 shows only a small number of the world's active volcanoes. So there are a lot of volcanoes here on Earth. There are far more than 31 or 32 or however many there are in this file. So it shows us how much silicon dioxide, aluminum dioxide, and iron oxide are inside of these magmas. And it tells us down here, use a different colored pencil. It's going to say use a different colored pin or different symbol to indicate the rock associated with each volcano as follows. So we're going to use andesite's going to be red, rhyolite's going to be blue, and basalt's going to be green. Because those are three types of igneous rocks, and those are the types of rocks we find at volcanoes. So we're going to come over here. We're going to start by giving this a good name. So we can call it Volcanoes or volcano mapping. You can add a little description, you can give it some more detail, so in the future if you do other mapping projects you have a little bit more background on what this is. So we've given it a title. We're going to want to title this layer. We're going to create a layer for each type of rock. We said there was andesite, rhyolite, and basalt. So if you're like me and you sometimes have a hard time spelling, you can come back and look at how to spell it over here. You can copy and paste if that's what you need to do. So we're going to make a map layer for andesite. We'll hit add a layer here. And now what are the other three types of rocks? Oh yeah, we can always go back. We have rhyolite. So I can copy rhyolite. I can name it here. And this one's just like our Google Docs and Google Spreadsheets and Google Slides. It says all changes saved in our drive. So we need to make one more layer, and that is for basalt. So we'll give it the name as well. Okay, so it says add places to this layer by drawing or importing data. So it says we need to add all the volcanoes in table 2.1. So I'm going to scroll down. This is this huge table. I'm not going to grab all of them in this video. I'm just going to help you get started on a few. So there's two different ways. We'll start with number 3 because we know Mount Rainier. It's in our backyard. So you can either type in Mount Rainier or we have the location of it here. And we'll do one of each way. So we're going to type in on Google Maps. We're going to type in Mount Rainier. Here. We're going to click on it. It's going to pop us up. It's going to zoom in on Mount Rainier. So we can zoom out. And we'll see if we're in the right place. We know Mount Rainier is in Washington. There's Buckley. There's Kent. We're in the right place. Auburn should be popping up around here somewhere if I zoom in. Okay, so we have Auburn. So we can click on this pin and we can say add it to our map. So we'll click add to map and you know it's got put down here under andesite. Hey, and we can change the color. There we can click and drag it. If it's not andesite, we can make it rhyolite. We can make it andesite. Let's go see what type of rock it is. Mount Rainier is andesite. So we're going to leave it up here in andesite. If we go back to the instructions, I have to scroll up to get to them. It says andesite should be red. So we are going to click on our Mount Rainier pin. We can click on style or this paint bucket and we can make it red. So there we have it red. And so what I'd like to do and what I'd like you to do is, this is a big list. I'm not going to remember which ones I've already done, and I don't think you are either. We can highlight the whole row. We can come up here to this A with a line under it, and we can highlight it. I'm going to highlight it red because we've already entered that one in. So now I know that I don't have to enter this one in again. So we're going to pick a rock of a different type. Looks like we have Yellowstone Park, Wyoming. I've never been to Yellowstone. My parents have. I'm incredibly jealous. I hope you guys get a chance to go there. But instead of just searching Yellowstone Park, we're going to use these coordinates. So we're going to come over here. We're going to type in 45N for 45 north. And what did it say its other coordinate was? Okay, 111 west. So we're going to type in 111 west. We'll hit search. It's going to bring up this pin in. And I'm betting this big green area is Yellowstone National Park. And yes, it is. So, we're going to click on our pin. We're going to hit Add to Map. Now I see it popped over here in andesite. But this one, if we look here, it says it's a rhyolite rock type. So we'll need to drag it to our rhyolite. Here, we're also going to need to rename it. So I'm guessing we can just click on the name to edit it. Oh, we cannot. There's this pencil here. I forgot about that. We'll click on the pencil, and it'll let us rename it. So we're going to rename it Yellowstone, Wyoming. Then we hit save. We also need to change the color of the pin. And this one is rhyolite. Our instructions say to color rhyolite as blue. So I'm going to come over here. I'm going to click on it. I'm going to color it blue. Oh, well, would you look at that? It's already blue. Ooh. So I've changed the color. There. So eventually, you will get a large number of volcanoes mapped on here. We're going to map one more. Where am I looking? At our table. We'll do Mount Baker, Washington. So we'll type in Mount Baker. Here, okay, and then we can see on Google Maps it says Mount Baker. I'm going to zoom out so I can see where that is. I know it's supposed to be in Washington State. We'll see if we're in the right place. Yep, Seattle, Tacoma. So we'll add it to maps. And I remember it was an andesite volcano. So I'm going to highlight it red. I think this is the red I chose before. I'm going to drag it up to this andesite layer. And before I forget, I'm going to go back to this one because we already completed Yellowstone National Park. I'm going to highlight that one blue since we've completed that one. And we're now working on Mount Baker, so when I finish it, we'll come back and highlight it. So we've already made it red, Mount Baker, Mount Rainier, so I can go ahead and highlight this one red. Click on the A with the line under it, click on red, there we go. So I've done 3, and it looks like there's 31 or 32 that you're going to have to do. Cool. So if we go back to the instructions, because it's more than just plotting the information on the graph or on the map, we have to think about it. We're going to see what it wants us to think about. Okay, so step 3 in the procedure says sketch lines where you think plate boundaries might occur. Says the relatively small amount of data you're using may make it difficult to do this correctly. So I don't expect this to be perfect. Perfect is just a practice one to see if there's any relationships, because we've already learned about plate boundaries and volcanoes. So on what basis did you determine the location of your plate boundaries? So you'll draw your plate boundaries on Google Maps, and then you'll type your explanation in this box. So I'm going to show you how to draw on Google Maps. So here you can see if we zoom out, we have 3 pins. And so we're going to zoom in and we're going to try to draw the plate boundary. So I remember in class we talked about the Juan de Fuca plate. Okay, so we're coming back together. It says we need to draw out a line on our map, sketch out our plate boundaries. Okay, so I'm going to click on this little line tool. And it says add line or shape, add driving directions. We're just going to add a line. And I notice my mouse has changed to some crosshairs. So I will click, and I see there's kind of a pattern right here. And then you can keep drawing however you think it's going to go. Oh, and then to end drawing, you double click it, and we're going to label it. And we're going to label it with where you think the plate boundaries might be. Let's see, step 4. So is it a divergent plate boundary or convergent plate boundary? 3. So I know this one because we've talked about the plate of Juan de Fuca in class. That is a convergent plate boundary, so we will label it convergent plate boundary, and we'll hit save. So when I click on this line, it'll pop up with the type of plate boundary that it is. There's also some other tools, like a little ruler, so we can measure. I've always wondered how tall our state is in miles, so our state is about 230 miles tall. Oh, so there's some other tools that you can play with in here. So I'm going to accidentally close out of my work, and I'll show you how to find it again. So we'll go back, open a new tab. We will go to Google, and we'll type in My Maps. So Google My Maps. Click on the first link. Because we added a name, I easily know which one it is. And we can load it. And now we're back to our assignment. We can zoom out. We can see the plate boundaries that we drew. But we still have a number of volcanoes still left to plot and a number of plate boundaries to attempt to draw out on our maps. So, as always on YouTube, you can pause, you can rewind to watch something again, you can freeze it. So you can read what I typed. Good luck, and I will see you guys in class.